just as I stated in my lecture that I'd continue on greenhouse effect in my screencast, here it is. I'm going to talk about the atmosphere. We have here our CO2, nitrogen, oxygen, water vapor, methane, all the gases that compose our atmosphere. And as we learned previously, all things radiate. It's just a matter of whether it's short wave or long wave. Hotter objects radiate shorter wave radiation, and cooler objects radiate long wave radiation. So here I'm going to demonstrate how the greenhouse effect works. Now our sun, being a hotter object, it radiates short wave radiation to the earth, and our atmosphere transmits that radiation from the sun, and that radiation reaches the surface of the earth. The ground absorbs that radiation and it converts it to heat. The Earth's surface re-radiates that radiation as outgoing long wave radiation, shown here. Now, our atmosphere, it allows shortwave to be transmitted. However, it absorbs the outgoing long wave radiation and it re-radiates that radiation in all directions. And some of that gets re-radiated back to Earth, as shown here. And so that, in a sense, warms the planet. If we did not have an atmosphere, our temperature would be around 0 degrees Fahrenheit. However, with the greenhouse effect and the trapping of the heat inside the atmosphere, our Earth's temperature is at a more comfortable average temperature of 65 degrees Fahrenheit. So here on the left side we have just a little demonstration of how it works in the everyday. Say you take your car, you go get groceries, or you go to the park, or whatever, and you just park it and you leave. The sun here, as we mentioned before, radiates long wave, or short wave, excuse me, radiation. And the windows of the car let that radiation come in. And the inside of your car then absorbs that energy and re-radiates that as long wave radiation. However, it can't escape through the windows because they do not permit long wave radiation to transmit. So the inside of the car is getting warmer and warmer and warmer, and the outside temperature, it could be 65, 70 degrees, whereas inside the car, when you come back, it could be 85, 90, 95 degrees. Blistering hot because of all that heat being trapped inside. So you don't want to leave your pets or your children stuck inside while you go get groceries or whatever, because they could suffer from exposure to heat. So a little transition now into a further explanation of evaporation and condensation. Here on the left we have, say, liquid water. Here on the right we have representing air and water vapor in the air. And at any surface of water, whether it's a cup of water or a lake, at the surface there where the water meets the air, there is a continue repetition of condensation and evaporation happening. Because as we know, all molecules move, they're in a constant state of motion. It's just a matter of how fast they are moving. So here in evaporation, what we have going on is the faster molecules move, the more energy that they have. So in order for the molecules of the liquid water to evaporate into gas, they have to gain energy. Now that energy is pulled from the air. So what happens as liquid water evaporates is you have a cooling effect on the surrounding area. Whereas on the opposite side, on condensation, in order for water vapor to condense into liquid water, it has to lose its energy. Well, it just doesn't lose it off. It gives off a warming effect on its surrounding area. So that's why when you are done with the shower and you step out of the shower into your bathroom, you are a lot cooler because you have more evaporation happening than you do condensation, which provides a cooling effect. If you stayed within the shower, where all that water vapor is in the air, you would have more condensation happening than evaporation, and you wouldn't be quite as cool. So that wraps up Chapter 7, Sections 4, 5, and 6.